Hello everyone. This is the basic block diagram of any generic optical amplifier. Here you can see this is the optical input signal, this is amplified output signal, this is the active medium, and this is the pump source. And these two are the fiber to amplifier couplers. So these signals are coming from the optical fiber, and this is also amplified output signal. This is also transmitted to the receiver, optical receiver via optical fiber. So in between this amplifier and fiber, there is a one device that is fiber to amplifier coupler, and in between this there is an active medium, and here is one pump source, and this pump source supply energy to this active medium. So the electrons present in this active medium get excited to higher energy state when acquire energy from this pump source. So as soon as this pump source supply energy to this active medium, electrons of this active medium get excited to higher energy state and create population inversion. And when incoming photon strike that electrons occupying state occupying higher energy state, then that electrons come back to the ground state and release the energy, and this transition is known as a stimulated emission process. And one incoming proton from here, we receive the photons. So one incoming photon stimulates many excited electrons to emit the photons of equal energy while dropping towards the ground state, and results in the amplified output, optical output. So basically, in any type of optical amplifier, there will be one external source that will excite the electrons, create the population inversion, and when the excited electrons interact with the incoming photon, the electrons get back to the ground state, and while doing so, they release the energy and give amplified optical output. So this is the basic principle behind the any optical amplifier. So if we observe the relation between gain and input signal power for any optical amplifier, then first here what you see, this G0. What is this? This is the zero signal gain, and this is around 3 dB. If we at Z0, what is the value? 30 dB. This is the gain, this is the input signal power. So as the input signal power is increases, initially the gain is constant, and after that it will decay, and if we go on increasing the signal power, then it gradually decays to the zero. So this is the variation between amplified gain and the input signal power. So we have seen the basic principle behind any optical amplifier. So optical amplifier can be divided into two categories. One is optical fiber amplifier, and which this is again divided into two, EDFA and FRA. EDFA is iridium doped fiber amplifier. In this, there is a doping of iridium in the optical fiber material, and in fiber Raman amplifier, this is based on the Raman amplification concept. And the another type is SOA. What is this SOA? SOA is a semiconductor optical amplifier, and in this we are using semiconductor material for the designing of this SOA, like phosphorus, gallium, indium, and arsenic. Basically, the alloy of semiconductor material from the group 3 and 5 of periodic table is used for the for this type of semiconductor, that is SOA. And so we will discuss OFA and SOA in detail. So first we will consider this EDFA. So basically is EDFA is a erbium doped fiber amplifier. As the name is stated, there is a doping of erbium material in the core of the optical fiber. So EDFA is what we say. EDFA is an optical amplifier in which this erbium ions are added in the core of optical fiber. So this is the erbium doped fiber. This is the input signal. This is amplified output signal. And basic principle we have seen that there is a pump source that excites the electron. So this is the pump source. Here we are using laser as a pump source, and from in this erbium doped fiber, the population inversion and stimulated emissions will take place. We will discuss this EDFMA in next video in detail. Thank you.